Hello everyone, welcome back to my channel and I'm Akshaya, pursuing second year engineering in SVC Bangalore. So today I have come up with a topic in the mathematics part, that is the variation of periodic current. So variation of periodic current seems physics, right? But how in mathematics? So let's see. So now coming to the introduction of variation of periodic current. So the variation of periodic current refers to the changes in the amplitude, free or phase, frequency or phase of an alternating current over time. Yeah, and it is essential to understand the mathematical concept behind this variation to analyze and design electrical system accurately. So basically, it is essential to understand because this mathematical concept behind this is to analyze and design of electrical system accurately. And by studying the mathematics of periodic current variation, we can determine the behavior and characteristics of electrical circuit. Yeah, so by reading this mathematical variation of periodic current, we can determine the behavior of characteristics of electrical circuits. So basically, what is variation of periodic current? Basically, it refers to the change in the amplitude, frequency, or phase of an alternating current over time. So this is the exact meaning of variation of periodic current. So the main aim we need to read this in the mathematics, that is because of to analyze and design of electrical system accurately. Yeah. So you saw the introduction part. Sinusoidal representation of periodic current. Yeah, what is this? So sinusoidal representation is commonly used to describe periodic current variation. So basically, it is being commonly used to describe the periodic current variation. Of course, a periodic uh, current interval of time, periodic time. Yeah. So a sinusoidal representation is commonly used to describe the periodic current. Yeah. So it is based on the sine function, sinusoidal sine function, relatable, right? Which represent the relationship between the current magnitude and time. So the sine function, which represent the relationship between the current magnitude even at the time. Yeah. So this was and the sinusoidal representation allow us to analyze and calculate various parameters. So this sinusoidal function or the period over periodic current over the time, representation allows us to analyze and calculate various parameters such as amplitude, frequency, and phase. So why they are saying sinusoidal representation of periodic current, as a periodic current, as the name itself is, over a period of time, so sinusoidal it's been happening. Yeah, so it is commonly used to describe the periodic current variation. That's why sinusoidal. And this sinusoidal, why? Based on sine function, which represent the relationship between the current magnitude as well as the time. Yeah, and it is used to analyze and calculate various parameters such as amplitude, frequency, and phase. One of the important part I've mentioned here, why sinusoidal representation of periodic current. Yeah. So next, coming to amplitude variation of a periodic current. So amplitude, everybody know about it. So what is this amplitude? Come, let's see. Amplitude variation refers to the change in maximum value of a periodic current over time. Yeah. So why this amplitude? Because it refers to the change in maximum value of a periodic current over a time. And it is often caused by factors. Amplitude is often caused by factors such as modulation, amplification, or attenuation. One of the important point in the amplitude variation that I've mentioned. So this is often caused by the factors such as modulation, amplification, or attenuation process. Yeah. By understanding the mathematics of amplitude. Yeah. Why amplitude in mathematics? See, and mathematics of amplitude variation. So we can evaluate the impact on power consumption and system efficiency. Yeah. So the important points I've included here is why the amplitude. Amplitude is caused because of the factors such as modulation, amplification, or attenuation. Why in mathematics, we can evaluate the impact on power consumption and system efficiency. So this was about the amplitude variation of periodic current. Of course, sinusoidal amplitude, relatable, right? Yeah. Next, coming to the frequency variation of periodic current. Yeah, frequency variation of periodic current. Of course, even the frequency SI unit, of course, everyone will be knowing hertz. Frequency variation describes the change in number of cycles per second of a periodic current over time. Yeah, so it can result from factors like harmonics, resonance, or modulation. So frequency basically, as the name itself, frequently. Yeah, frequency variation describes a change in number of cycles per second. So it's SI unit is also of course in one unit. By studying the mathematics of frequency variation, we can analyze the impact on signal integrity and system stability. Information of frequency I have given, physics related part, everyone. So by why mathematics? Yes, because we can analyze the impact on signal integrity and system stability. One of the important point I mentioned, the frequency variation of periodic. Yeah, phase variation, amplitude, frequency, phase. Let's see. Phase variation of periodic current. So the phase variation refers to the change in starting point of a periodic current waveform over the time. So what is phase? Of course, everybody know about it, but one simple definition, right? Phase variation refers to the change in the starting point of a period current waveform over the time. Yep. And it can occur due to the factors like phase shifting, synchronization, or modulation. Of course, this phase occurs only when there is a tremendous move or a phase shifting, synchronization. Yeah. And understanding the mathematics of phase variation is crucial for synchronization of different electrical system. So we in frequency, mathematics related to frequency, why need to learn? Because it is of the signal integrity. And why phase variation in mathematics? Let's see. Understanding the mathematics of the phase variation is crucial for synchronization of different electrical systems. That is one of the important part. Why phase in mathematics? We'll be learning. So why synchronization of different electrical systems? So the phase, as a phase itself says, it is for the modulation or the shifting or the synchronization. So all these activities do come, but why in mathematics? You can easily tell this point for is crucial for synchronization of different electrical systems. So we learned about frequency, amplitude, phase. Next, coming to the mathematical equation of periodic current variation. Yeah, as we learned so far about frequency, amplitude, and phase. Now, what is the mathematical equation as we are dealing with maths? So, why the of course equation, addition, subtraction, multiplication, blah blah blah, everything need to come. So, several mathematical equations exist to represent the variation of periodic current. So, these equations involve parameters. So, not a particular equation, but these equations involve some equations like parameters such as time, amplitude, frequency, and phase. That what we learned so far. Yeah. By using these equations, we can analyze and predict the behavior of periodic current in the different scenarios. What was it? These equations involve parameters such as time, amplitude, frequency, and phase. So this was the mathematical equation. It involves sub-equations. That's what I have mentioned here. And by using this equation, we can analyze and predict the behavior of periodic current in different scenarios. So this was related to the mathematical equation. Yeah, that's what we learned. But there's a particular equation, but this equation involves parameters such as time, amplitude, a group of bundle, yeah, like that. Next, coming to the Fourier series analysis of periodic current variation. So, Fourier series analysis is a mathematical technique. First, let us know what is Fourier series. Yeah, it is a mathematical technique used to represent a periodic current as a sum of sine and cosine function. Important point I have mentioned here. Let's understand it. So, it is a mathematical technique used to represent a periodic current as a sum of sine and cosine functions. It allows us to decompose a complex wavefront into a simpler sinusoidal components. It allows us to decompose a complex into a simpler one. Easily understand by using a sinusoidal functions or a components. Yeah. By applying Fourier series analysis, we can determine the amplitude phase of each harmonic component in a periodic current. So first, we understood what is Fourier series. So it is a technique used to represent a periodic current as a sum of sine and cosine function. Yep. It allows us to decompose a complex waveform into simpler sinusoidal components, large equations into small equations. Easily, we can remember it. By applying Fourier series analysis, we can determine the amplitude and phase of each harmonic component in a periodic current. So this we learned about Fourier series. Next, coming to the what is the present application periodic mathematical and electrical engineering. Yeah, what are the applications? Mathematics of periodic current variation is extensively applied in electrical engineering. First, everyone would be wonder application of periodic current. Why in maths? So we dealt with why in mathematics of frequency, amplitude, and such thing. Now, what is the main application? Why we need to do it in especially in math? Answer is here. The mathematics of periodic current variation is extensively applied in electrical engineering. So there it will be useful. By yeah, it helps in designing efficient power distribution system, analyzing the behavior of electrical circuits, and optimizing signal processing techniques. Yeah, one of the important point. By utilizing this mathematics, engineers can ensure reliable and stable operation of electrical systems. So engineers, everyone would have think only just coding. Oh, they can become. Engineering is not just about only coding, mathematics, coding, and what the skills he have all together form an engineer. Remember this. So that by utilizing this mathematics, engineers can ensure reliable and stable operations of electrical system. Engineers do follow each and every subject or use every subject in day-to-day application, even uh, without coding also. Yeah. So these were the few applications important applications I've mentioned here. And what are the challenges and limitations of periodic current in mathematics? Yeah, few challenges and limitations should be there, right? So let's see. The mathematics of periodic current variation has certain challenges and limitations. Complex waveform may require higher order Fourier series analysis, increasing computational complexity. Non-linearities and transient effects can make the analysis more complex and may require advanced mathematical techniques. So some of the concepts and limitations of the periodic method. So important points you can get it. So hope you guys now you guys got a bit knowledge of why periodic variation of current. Yeah, so we dealt up of amplitude, frequency, phase, and the two wide mathematics. Being in mathematics, what is its application, challenges, limitations. Now coming to the last part, conclusion. The variation of periodic current mathematics is essential for understanding and analyzing electrical system. Important point. It allows engineers to predict and optimize the behavior of periodic current in various scenarios. Of course, by applying this mathematics concept, we can design efficient and reliable electrical system. As the name itself says, variation of periodic current. Everyone would have got idea about physics in mathematics, and that too why important application in electrical engineering. So this was my video about variation of periodic current in mathematics. Hope you guys liked it. Please do like. Thank you.